Right. Happy Thursday. Happy week 2 or culmination of week 2 just about for at least math blocks here. I'm going to go through our PowerPoint as we normally do, kind of talking about our agenda and whatnot. But first off, let's start off this class by going over some Virtual Spirit Week. Today is TV Thursday. Share a new favorite. I will be going over that. Also, I took a picture of my puppy and I for WAG Wednesday yesterday. So starting off with that today, there's a little selfie I took of her. She kind of started to lick me right as I started to take the picture. So there's my WAG Wednesday selfie with my puppy. And then let's see. Here's our Tech Thursday or TV Thursday, I think is what it was called. I've been watching Westworld a little bit more frequently seasons, so I can't really watch all that frequently. And my favorite movie I've watched thus far, since I love climbing, has been Rail Rock 14, which is a collection of short films on climbing. So that is my TV Thursday. Does anyone want to share either what you've been watching or a picture of your pup or I guess any animal selfie? Let's see, why is it not letting me go back? All right then, cool. No worries, no stress. Hopefully everyone's doing well. Let's go back to where we're at. Okay, so hopefully everyone is doing well. I wanted to do that kind of virtual spirit week again, kind of to wrap it up. But also I wanted to give a shout out to some of you. I know you've been working hard, both in classes and doing other projects. I actually ran into one of y'all yesterday at Trader Joe's. And a student informed me that he was going out and buying groceries for people who couldn't get outside. If you're doing something like that, using this time to make a positive difference in our community, then well done, good on you, and shout out for that. And again, so shout out to those who are doing projects, making a positive impact despite the troubling time that we're in. So good on you for doing that. Okay, so I wanted to also kind of address some of our remote learning agenda questions and also our remote learning questionnaire. So just a heads up, when I call the remote learning questionnaire or the RLQ, that's these things right here. I've been getting some really good questions on those. Please feel free to check those out. I'll be posting this one for today and tomorrow in about 15 minutes. Actually, maybe right after this conversation. But always feel free to contact me anytime I get a response. I check these, I pretty much have these up on my browser regularly, and I try to get back to you ASAP. So if you have questions, I'll either contact you personally via email or create a video if you have a specific homework question, or I'll address it like I am right now on the Zoom session. So I want to empower y'all to continue to do that. Also, couple questions I've gotten on the kind of process of this class, and I appreciate y'all asking these. Ed puzzles, I've been getting a lot of questions about the Ed puzzles. Are they mandatory? What are they kind of all about? What exactly are they? Ed puzzles are basically equivalent to classwork. So what I mean by that is, since we can't meet together or aren't meeting together more than twice a week right now and on Tuesdays at this time, I wanted to assign Ed puzzles to kind of give us some sort of lesson / direction as to what the material's on. So effectively, they're equivalent to classwork, therefore I'm grading them upon completion. Now what I mean by that is, regardless of what you get when I return these to you, and if you completed the Ed puzzles, you may know what I mean by now on that. Like you might get like a 1 or 1.5 out of 2, or maybe a 2 out of 2. Regardless of what score you get on that, at the end of this unit, I'm going to go back and I'm going to give you completion points. So it doesn't matter whether you get them all right or all wrong. As long as you're trying it, I will give you points for trying it, because it's classwork. It's just going to be based on completion. I'm only assigning them to basically the work. So my recommendation is, please do them. Please watch those videos and follow along with the Ed puzzles, because they're going to be used in conjunction, meaning together with these Zoom sessions, and they might help you understand the material a little bit better. So try those out. Also, big shout out to y'all for the effort level and the participation level thus far. I know this is a very big adjustment, so this whole thing has been different, so I do appreciate y'all working hard. Continue to follow along with the Google Classroom and the remote learning agenda. The remote learning agenda is this thing. Okay, so basically the Google Classroom, if it's on the Google Classroom, you should do it. If it's not on the Google Classroom, you shouldn't do it, to put it simply. If it's on the Google Classroom, it's also probably located somewhere on this remote learning agenda. And these are kind of your guidelines for success, what we're going to be doing through this whole process. So for example, today's the 26th, we're going over lesson 18. There is an ed puzzle that goes with it. I know some of you already completed it. And the textbook assignment, that is just your homework assignment. It is just the homework assignment from the text, and that's the highlighted problems there. So kind of just quick shout outs and trying to answer these questions on a broader level. I know it's probably just hearing me talk at that, but I really do appreciate how hard y'all been working and your adaptability and flexibility with this. It means a lot to me, and I'm sure it's been an adjustment for you, but I know you're working hard, so I do appreciate that. Basically, this kind of second bullet point in the effort and appreciation category, do your best. Since it is a change, if at the end of this process you can say to yourself that you really did give your best effort in this class and your other classes, then that's a success in all of our books, both as teachers and administrators at Valencia High School. And I'm not an administrator, but I'm sure I can speak for them in saying that they do appreciate your effort level. Never hesitate to ask questions. We're to kind of touch on that email or the RLQ forms. Kind of quick typo, I wrote RLA there, but RLQ. All right, cool. So today, to get into the material, that's all of our agenda. This morning, a comprehensive review assignment was posted. Notice that technically speaking, we're not going to go over that assignment or the review until a week from today, April 2nd. It got posted a little early, which is fine. Someone already completed it. Well done. I want to mention that this comprehensive review assignment, this thing that just posted on your classroom, top of the stream other than this Zoom session, do not do that right now unless you've already completed all the other ed puzzles and assignments. That is the review assignment for this entire unit, okay? All of logarithms and exponents effectively. So when you see this thing right here, the CRA, do that after you've completed all the other homeworks and all the other ed puzzles. It is effectively what we a test, but it's not going to count as a test here because of the remote learning situation, but it is just basically a wrap assignment last. That is not due until I believe the 17th. So like 3 weeks from now. Take your time on that, okay? You can, if you need to redo it, contact me, I'll reopen it for you. All right, that's all kind of our busy work out of the way, kind of talking about details of this class. So before I move into today's learning agenda, today's quick lesson on solving log equations, does anyone have any questions for me? Right on, okay, cool. Cool, all right, lesson 18. Today, this is basically the culminating lesson of this entire unit where we've been using these different logarithmic properties, which was mostly lessons 14 and 15, our product, quotient, same base, power, and reciprocal properties. We talked about change the base formula, and now we're combining all of that with our major algebra goal of solving equations. So basically combining all of our skills into one skill, solving equations, and we're going to be doing so with 4 problems on again, this is from our text. We're going to be doing 3, 13, 16, and 17. Just a heads up on this, everybody. We actually have a bunch of videos up on the YouTube channel already about this. I've already done some of the homework problems on this, but you can always go back and reference both this Zoom session and those other videos for more work on this. All right, so lesson 18. I'm going to start off here on the lesson summary, which is on page 239. First thing I want to talk about, let me grab my iPad. First thing I want to talk about here is translating a logarithm to an exponential equation, aka following that purple arrow. This is kind of what we've been learning that logarithms are. Logarithms legitimately answer, like the answer to a logarithm is an exponent. So building off of the last unit we were in, when we were talking about solving exponential equations, like things circled in black, we're now using logarithms to answer unknown exponents. So effectively, what this first step is saying, if we're trying to solve a logarithmic equation, we could turn it into an exponential equation and then solve. Example number 1, boom, right here. By the way, this was recorded on another video already, so you might be seeing this. You're not going crazy. It is a double up. But effectively, if I wanted to solve this equation, log base 2 of the argument 1 minus x equals 4, what I should do is I should turn that into an exponential unknown where my base is that blue 2. The answer to the log is always an exponent, so that's my exponent, 2 to the 4th power. And this logarithmic equation is equal to the argument 1 minus x. You see that worked out over here to the right, okay? Second method of solving a logarithmic equation would be kind of that similar logic that we talked about back in module 5 when we talked about fraction equations. We call them rational equations. For fraction equations, we understood the logic or the kind of idea behind once we set our denominators equal to each other, we could just focus on our numerators. Well, this kind of follows true here. And with our knowledge also last unit of change of base formula, and that's the following, that if you have logarithms with the same base, like log base b of x equals log base b of y, well then all you got to do to solve this is focus on where they're not the same, aka the arguments. So if you have two logarithms that already have the same base, this is ideal because all you got to do is set the arguments, in this case x and y equal to each other. We have this example right here where I have a log base 10 of the argument x to the third. I'll kind of highlight this in blue. A log base 10 with an argument x to the third equals a log base 10 of 27. Since these are both just common logs, log base 10, all we got to do is solve down our arguments. X to the third equals 27. That's done by taking the cube root of both sides. Okay, so that's the general idea behind it. Extraneous solutions are extra solutions, or they're answers that solutions that are actually impossible. Okay, now in the context of fraction equations, rational functions, we said those are things that made the denominator equal to 0 because we know we can never divide by 0. Extraneous solutions in this unit are basically anything where your argument is equal to 0, because you can never have an exponential function 4 to some power can never be less than or equal to 0, okay? Because we know that the lowest x could be would be 0, and that would always be equal to 1, and 1 is bigger than 0. Or if you have a negative exponent like 4 to the negative third, we use our reciprocal logic. So effectively, if you have an exponent, the answer is at most, or at biggest, always going to be some sort of decimal, positive decimal. So let's actually get to the material here today. We're going to start off on the next page, which by the way is page 240, problem number 3. I'm going to kind of jam through these pretty quick here. On page 240, problem number 3, I have the logarithm base 2 of the argument 49x squared equals 4. What I've done here is I have translated this equation already into an exponential equation. I liked method number 1 on the last page, turning into exponential and then solving. Kind of follows very systematically and logically with what we've done in Algebra 1 and Algebra 2 to this point. So long story short, I tried color coordinating this for ease of seeing that the base is 2. Our exponent is 4 because that is our answer to our logarithm. And then it's equal to the argument 49x squared. And now all we got to do is evaluate. 2 to the 4th is 16. Yep. And now it's just SADMAP working right to get rid of multiplication via division. I'm just going to leave that left side as a fraction. Okay. Because now I just have x squared. And we can isolate x by undoing the power of 2 by taking the square root of both sides. And when we square root, and the reason why I left the left side as a square root is because when we square root an entire fraction, I'm going to zoom in real quick, and I'll zoom out in just a second, but when we square root a fraction, radical properties of division basically say we could turn that into a square root of the parts of the fraction, numerator and denominator. Sorry, that 4 didn't turn out too well. And now this is really easy to take the square root of because the square root of 16 is 4, and the square root of 49 is 7. So again, I like to work with the process of turning it into an exponential unknown, as you can see, or an exponential equation, seeing being circled in blue, because then all I did from there is I used all of my kind of tools of algebra, evaluating, and then isolating by using opposites. That's number 3 on page 240. So as I kind of go back and erase those highlights, does anyone have any questions on this process? Want me to repeat anything, or does anyone need me to keep this on there for a few more seconds. If not, I'm going to keep it on for about 10 seconds and cruise on down to my next number, which will be problem 13. If you need me to slow it down or do anything, feel free to hit me up in the chat box, okay? Because I have the chat box now open as well. All right, then, moving on. Next page. Maybe not next page. Sorry. Second to next page, because you notice all of this stuff is already done. There's actually videos explaining those ones on the YouTube channel already. Check them out. They're good. I may say so myself. Okay, page 242, problem number 13. I've done the translation again. Again, what I did here is I turned this logarithmic equation, not as ideal in my opinion, into an exponential equation, and then I went about solving for x. I love number 13 even more because guess what? X is already isolated. It's already by itself, which means I don't have to undo anything with SADMAP. All I got to do is evaluate down the left side of this equation, take the fourth power of root 2. Keeping in mind, y'all, that I'm just going to kind of do this the long way. You know you can evaluate this with a calculator. I'm cool with that. But what I'm going to do here is I'm going to turn this into the square root of 2 into 2 to the 1/2 power, just to kind of get a little bit more practice with these properties of exponents, turning a radical into a rational exponent. Then I'm going to use my properties of exponents to work this down. And what that property of exponents is that when you raise a power like 1/2 to a power 4, you actually multiply those exponents. So this turns into 2 to the 1/2 times 4 equals x, but 1/2 times 4 is just 2. So really what we now have is 2 to the second equals x. Keep color coordinating a little bit here. And 2 to the second is 4, therefore x is equal to 4. All right. Cool. Moving along. Since it looks like everyone's cruising through this that I can see. If you have a question, raise your hand. I do believe there's raise hand capability, or unmute yourself and just holler at me real quick because I'm moving on to number 16. Okay, number 16 is arguably, in my opinion, the hardest problem of today's lesson because it involves a logarithmic property in it. And the way that I know that is, one, because of what I'm highlighting in blue right there. Since I'm subtracting two logarithms, I'm really using my quotient property of logarithms. Hold on, right before I continue, can everyone hear or see me? I just got a notification that my connection's unstable. We all good? Okay, I'm still seeing y'all moving, so I'll take that as a yes, and someone said no. Cool. All right, so since we are subtracting two common base logs, and what I mean by that is a log base of 4 minus another log base of 4, I can leverage this quotient property. And what the quotient property really tells me is the following. That working backwards with the quotient property, what I can do is I can take these two arguments, which I'm going to highlight in green, x plus 3 and x minus 5. And I can turn this into one big logarithm, that the log with a base of 4 is really dividing these two arguments, x plus 3 over x minus 5. And let me show you actually with maybe proper coloring here how I got that. Boom, blue. So effectively, kind of to reiterate the process, what I did here is I turned it into one logarithm by using the quotient property. And the quotient property says that since these two logs have the same base 4, I could turn it into one logarithm with a base 4 by taking these two green arguments, x plus 3 and x minus 5, and dividing by them. All right, so now all we have to do is break this down and solve it by creating an exponential equation. So here we go. 4, our base of 4 to the power of our exponent 2 is equal to, actually let's just write this out, that argument, x plus 3 over x minus 5. Okay, so again, I turned it into one big logarithm, check. Then I translated that logarithm into exponential form down here, awesome. Now all I'm going to do is evaluate and solve this down. And that's not going to be too hard at this point because 4 squared, that's pretty easy stuff, 16. And that's equal to this ratio over here, which I'm going to copy and paste for sake of time. Now we learned back in rational functions that if we have equations that are made up of ratios or fractions. One way that we could do so in this case would be to cross multiply. So I'm going to cross multiply here, keeping in mind that 16 is just 16 over 1. So I could still cross multiply there. But effectively what I now have here in purple is 16 times x minus 5 is equal to the product of x plus 1 times 3, which I showed as a highlight in red, which is just x plus 3. Sorry, I said x plus 1 times 3, but x plus 3 times 1. Now a little distribution, boom, boom. 16 times x minus 16 times 5 is equal to x plus 3. And now you're probably like, okay, cool. I know how to do this from here. Multi-step problem to solve. I'm going to subtract x on both sides. Just finish it off real rapid fire here. I'm going to add 80 to both sides. X's and 80s are gone, leaving me, let me get this off the screen here, leaving me with 15x is equal to 83. And then yes, we just divide both sides by 15. Sorry, I'm running out of room. And here's our answer. So that was a lengthy one, and I kind of started off this problem by saying that this would be the hardest one, primarily because, as I put my iPad down 1 second, because we had to start off by using the quotient property to turn it into this thing that I'm highlighting in red right now, a single logarithmic equation, because once we did that, we could move it into an exponential equation and then leverage our skills in algebra to solve down our x, isolating it.
Mr. Benham, we can't hear you.
Opposites. I'm sorry, what's that? I just, I heard a comment. Are we all good? Good?
Yeah, we can hear you now.
Yeah, you're good.
Did I cut out for a second?
Yeah.
Okay. All right, cool. Does anyone need me, since I cut out, to go back and repeat any of the process?
Yes, please.
All right, the whole process or which part?
I don't know.
Okay,
Whenever you started drawing the red arrow.
Yeah, that
I started
part.
drawing the red arrow. Thank you. Okay, cool. All right, so when I was drawing the red arrow, what I was saying was I was just kind of summarizing the steps. But when I drew the red arrow, I basically was saying once we got to a single logarithm by using the quotient property, I was just turning it into an exponential unknown, which is where the red arrow was leading us to. And then I was using my algebra skills from there to break it down and solve for it. So that's kind of, it was just kind of mostly a summary of the problem. Cool. Sorry about the unstable internet. I don't know what's up with that. A lot of it's working from home right now, I'm sure. Okay, last one. Last one. Again, this is all being recorded, so feel free to check this out on the Zooms, on the YouTube channel soon. I will post another link to it, and if in chance that you don't know how to access it. All right. I'm gonna go wild card here. I'm gonna ask, does anyone want to try to explain how to solve number 17, or at least
It's
how to set it
happening
up
again.
into exponential? Thank you, Chris. Can you hear me now? Yeah? No? I seem frozen. Okay, it looks like I might be frozen. At least y'all are frozen, so. Hello, hello.
Has cost for 15 years. According to my doctor, I don't have another 15 years if I want to keep up the same dietary and sexual lifestyle, which I intend to. Oh, no, silly. My next boss will be my last boss. He'll be at my funeral.
Hello,
so
hello.
I would appreciate it if you would take this serious.
Natalia. Hello. Oh my gosh. All right, everyone. I don't know what's going on. Connection seems to be really bad right now. So, yeah, I think I'm going to record number 17 as a singular video. Other than that, I think I might have to call it. We are down to our last 5 minutes. But yeah, it looks like I've kind of lost most of you anyways, based on the presence. So connection was bad today. My apologies for that. I don't know why it happened, but feel free to email me or use the remote learning questionnaire to ask me questions. I will record number 17 as a standalone video. My apologies for the inconvenience. If you can hear me, I hope you all have a great rest of your day and a fantastic weekend. I'm sure I'll talk to some of y'all over email in the near future. Bye, everybody.